All right. So we talked about the mechanics of plate tectonics. Looking at the first question on the exam you guys just took, I realized there were a lot of questions on there on what was pretty new material for you guys. I actually had some trouble finding enough answers that started with the right letters. So that bias, well, I won't say bias, but that may have made things a little bit difficult for people. I'm just going to grade them this weekend, and then we'll see if there's a curve merited or anything like that. No promises, but we'll take a look at that. And where I left off, we were talking about this new model that we have of the Earth, which is surprisingly dynamic, um, very slowly but very constantly remodeling its surface. The outermost layer of the Earth is called the crust, and it can range from just a couple of miles thick at the mid-oceanic ridges to something like 60 miles thick under the Himalayas. But when you remember that the Earth is, what, 7,800 miles in diameter, the crust is still very thin. If you could shrink the Earth to the size of an apple, the crust would be roughly the thickness of the peel. And one type of crust makes up the continents. Um, Oceanic crust, which is a little bit denser rock, makes up the deep ocean floor. And the outer layer of the Earth's crust, is broken up into roughly 20 tectonic plates. And what moves the plates is the fact that they are riding on top of the upper mantle layer. The upper mantle layer is called the asthenosphere, aka the weak layer. And what we think is the driving force, maybe possibly people argue about this. Let's not get into that. That's a whole another course in the first place. Is convection in the asthenosphere. The asthenosphere, circulates very, very slowly over the course of extremely long time periods. And what happens is that rising rock comes up this way and pushes the plates apart at the mid-oceanic ridges. Rising rock comes up through here. It actually melts right as it gets to the ridge and pushes its way in between two plates and forms new sea floor. Sea floor is constantly being made at these mid-oceanic ridges. The youngest rocks on the bottom of the ocean are the ones that are forming now in places like the middle of the Atlantic. That pushes the plates apart, and when two plates meet, if they're both continents, they'll both crumple, and you get a type of mountain range called a fold belt. And you know what fold belt mountain ranges looks like because you live on the edges of one. The Ouachitas are a beautiful example. You can drive around the Ouachitas and see places where the formerly horizontal rock layers have been bent and tilted and tipped every which way. But if a piece of oceanic crust crashes into a continent, the oceanic plate is driven downwards in the mantle, and eventually, given enough time, given a few millions of years, will eventually just kind of melt back into the asthenosphere, and really given enough time, end up getting recycled on the course of probably tens of millions of years. But as this plate sinks, what we get is let me get a more contrasty color here for you, is we get a trench on the bottom of the ocean. These are the deepest parts of the ocean. The Marianas Trench is in the Pacific Ocean, not far from the island of Guam. And the deepest part of the Marianas Trench is, I believe, 39,000 feet deep. In other words, it's so deep, in theory, you could sink Mount Everest in it and it wouldn't break the surface. Maybe 36,000 feet deep, but still, Everest is 29,000 feet high. So yeah, you could sink the highest mountain in the deepest ocean and it wouldn't even break the surface. So these are very deep parts. By the way, James Cameron, I don't think he's released the footage yet, but he used his money from making Titanic to actually build a submersible vehicle that could actually withstand conditions down there. So he's actually gone down and looked. Anyway, so you get the trench, and right here as the plate begins to melt, you have liquid rock pushing its way up and creating a chain of volcanoes called a volcanic arc. In some cases, the volcanoes make islands, and we call it an island arc. Indonesia is a great example. In other cases, like the Cascade Mountains of Northern California up through British Columbia, the volcanoes end up as part of the continent. So Mount St. Helens and Mount Rainier and Mount Hood and Lassen Peak and Mount Shasta and all of those are an volcanic arc that doesn't make islands. It makes a range of mountains on a continent. So anyway, that's our basic picture of how plate tectonics works. And continental and oceanic crust form tectonic plates, and these are the main ones. These little arrows, if you can see, show the directions of plate movement. Like here in the middle of the Atlantic, the plates are moving apart. In places like the Aleutian Islands right here, or the Kamchatka Peninsula and the Kuril Islands right here, the plates are moving together, and that's where you have some big subduction zones. Indonesia right here is one of the biggest and most dangerous. The eruption of 1815 of the island of Tambora actually altered global climate considerably. It put so much volcanic ash and gas into the atmosphere that it noticeably blocked the sunlight. And 1816, the year after that, is still known in European history as the year without a summer. Yeah, there were global cold temperatures because of Tambora. Krakatau also blew up here in 1883, and that killed 35,000 people and created a sound that was heard 2,600 miles away. So yeah, subduction zones are where you get the killers, the most dangerous earthquakes and the most dangerous volcanoes. So in some places they're sliding apart, in some places they are moving together. Here, where one continent has hit another, where India has slammed into Eurasia, you're getting the building of a fold belt mountain range. This is where the Himalayas are. And in a few areas, they're sliding past each other. There's the San Andreas Fault, where the Pacific is moving to the northwest relative to the North American plate. And the San Andreas is a transform boundary where plates are scooting past each other. So, very dynamic Earth. What's this got to do with anything? Well, here's a wrinkle I didn't teach you guys about. There are some points in the